Okay, let's do an example. So again, let's do one with M&Ms. Suppose that somehow we know 30% of all M&Ms are green. Then my population is M&Ms. I've decided to call success being green. The other possibility is not green. My population success rate is 30%. 30% of all M&Ms are green, 70% are not. Now we go out and we collect bags of size 200. So my N here is 200. So we need to check these conditions. We kind of already talked about this. The samples need to be random. If there's a mistake at the factory and I get a bag that's all blue M&Ms, well, that's just a crappy sample. Samples need to be independent. Counting your bag shouldn't influence other people. 200 is definitely less than 10% of all M&Ms. There are a lot more than 2,000 M&Ms out there. And then we need to check this condition. So N times P, 200 times 30% is 60. That's bigger than 10. 200 times 0.70. N times Q is bigger than 10. We meet all these conditions. So the central limit theorem applies. I'm allowed to use the central limit theorem. Then that says that the average of all possible bags of M&Ms will be 30% green. Again, that means if I send every one of you out and I say, find me 45 bags, a lot of bags of M&Ms, and we bring them all into a room, and we open up every single bag, and we find the fraction green in each one. So we got a number. Each bag has one number. 20% green, 60% green, 15% green. Then we average all those percentages together, we'll get the population average or population success rate, 30%. So here is a graph of all possible bags of M&Ms. The average is 30%. The standard deviation, you got to be careful typing this in your calculator. Square root of PQ over N. Again, if you don't know what the letters stand for, you're not going to type this in correctly. So you have to know what P, Q, N, P, you have to know what all the letters stand for. Okay, now we can answer questions about bags of M&Ms. I want to know what fraction of all possible bags would have more than 34% green. So now we're in a chapter 5 problem. This is a test 1 question now. It's just a normal distribution problem. I know the mean, I know the standard deviation. I follow my same 3 steps that I've always done. Draw the picture, find the z-scores, normal CDF. So my average is 30%. I want to be bigger than 34%. I want my sample mean, my sample success rate to be more than 34%. So I shade above that. Okay, now we've got a brand new formula for z-score. We're going to have 6 different formulas for z-score this semester. Don't memorize all of them. Our new formula is now, remember before it was x minus mu over sigma. Now it's p hat minus p over SD. Don't think like that. Think the one you want, the one in the question, minus the one in the middle of the picture you just drew, divided by whatever standard deviation you just calculated. So we do that and we get 1.33. So that bag of M&Ms is 1.33 standard deviations above the mean of 30% green. And then normal CDF, lowest thing we shaded, his z-score up to highest, we shaded to infinity, we get 9.2%. So that doesn't mean, a lot of times people will write sentences like 9% of M&Ms are 34% green. Think about what I just said, 9% of M&Ms are 34%. An M&M can't be 30% green. And M&M's either green or it's not. We're not talking about all M&M's. If you say 9% of M&M's, I don't care what you write after that. It's all wrong. It's 9% of bags of M&M's of size 200 have more than 34% green. We're making predictions about samples, not individuals. Okay, what percent of bags would have less than 28% green? So we draw a picture, our p hat that we're after, our sample success rate is 28%, said less than, so we're going to shade below. Find our z-score, the one we want, minus the one in the middle over the standard deviation. Normal CDF, the smallest thing I shaded was negative infinity up to this guy's z-score. That's a typo. That should say yeah, something's, oh wow, there's a lot of typos in here. This is not correct. Let's do this one live now. I mean, look at this. That's clearly a negative z-score. That bag of M&Ms is below the mean. That should be a negative z-score. Clearly, I did not shade 75% of that picture. So that's clearly wrong. I'll fix this document and re-upload it. So if you look at this later, you'll see the correct numbers here. Okay, so what we want, distribution, normal CDF, negative 99 to, was it negative 0.67? Yeah. Remember, never change mu or sigma there. 25%. So this should say 25% of all bags of M&Ms of size 200 are less than 28% green. Remember, we're making predictions about samples, not individuals. Okay, we got Dave again. Anytime you see Dave in a problem, he's probably making an outrageous claim. He's made this claim that he's got himself a bag of 200 that had 80 green in it. We want to comment on what we think about this. So remember, we have three variables, x, n, and p hat. X is the actual number green. P hat is the green rate or percentage. You want to have this memorized. P hat is x divided by n. 80 out of 200. So 80 actual green, 40% green. We need the p hat. So we draw our picture. Right in the middle is our average bag, 30% green. I want to be, now remember, normal distributions, you can't find the probability of hitting a number exactly. I can't tell you, using this model at least, the probability of him having exactly 80 green. I can only do green or 80 and above. So you always have to shade something. If you're not told above or below, always shade a tail. So I'm going to shade this tail above 40%. Find the z-score, the one I want, the p hat I want, minus the one in the middle over standard deviation. Dave's bag was 3.33 standard deviations above the mean. We type that in our calculator. I want you to see this. You have to be on the lookout for these scientific notation problems. 3.33 to 99. That is not 400%. Normal CDF will never spit out something bigger than 1. You can't have more than 100%. That's 4 times 10 to the negative 4th. If you ever get something here bigger than 1, that's because there's scientific notation at the end. So that's, if you convert it to a percentage, 0.04%. It's an incredibly tiny number. So only, not 4%, not 0.4, 0.04% of bags of M&Ms would have 40% green or more. So the way I see it, there are 4 possibilities here. When somebody makes an outrageous claim, outrageous claims or extraordinary claims require extraordinary evidence. So if somebody makes an outrageous claim, your first thought should always be that person is a liar. So that's our first thought. Dave's just a liar. But then let's say we went and checked Dave's math. So we went over and we looked at his M&Ms ourselves. And we say, okay, no, he didn't lie to us and he did the math correctly. So that's the second thing we want to check. Did he mess up? Well, then what's the next possibility? He actually got this bag of M&Ms? My next thought would be, well, there must have been a mistake at the factory then. There was something wrong with that machine. The machine should not be spitting out 40% M&Ms when all the other bags have an average of 30%. So the next possibility is it was probably a bad sample. But now, let's say, for example, we went to the factory and we checked that machine. And we made sure, spam calls. We made sure that that machine was actually okay. We checked it and it was a good sample. It looked like the population. Well, our next possibility is stuff happens. Samples vary. Some percentage of all samples will look like that. It happens. If you go out and grab billions and billions of bags of M&Ms, some of them are going to be up here in this range. Maybe Dave just got lucky and got a really weird bag of M&Ms. But then there's another possibility that we need to consider. Everything we've done here, all of this, is based on a phone call we made to the Mars Corporation where they told us 30% of all M&Ms are green. Maybe that was wrong. We call this hypothesis testing. This is what we're going to do in a few weeks. We think we know something about the population. We do a sample and that sample contradicts what we thought we knew. We have to be open to the possibility that what we thought we knew might be wrong. So the last possibility is maybe more than 30% of M&Ms are actually green.